Hi everyone, I'm Christina and welcome to the third video in our A-level trigonometry series. In the last video, we looked at the compound angle formulae for sine, cos and tan. And in this video, we're going to build on that and look at the double angle formulae for sine, cos and tan. So in this video, our objectives are to derive sine of 2x, cos of 2x and tan of 2x. So these are the double angle formulae, and to also understand that there are three different forms of cos of 2x, and we're going to look at how we get all three of them. So we're going to have to refer to our compound angle formula to get to our double angle formula for each. So let's start with sine. So sine of 2x is equal to, well, we can rewrite this as sine of x plus x, because now it's in the same form as our compound angle, where a and b are both x. In which case, we can continue writing this, referring to the formula, to the compound formula, and we can write sine a cos b as sine x cos x. Plus, we do the same thing for the second term, sine b cos a becomes sine x cos x. So sine x cos x plus sine x cos x, that's two lots of sine x cos x. So it just becomes 2 sine x cos x there. Make that a bit clearer. Okay, and that's our first double angle formula for sine. So sine of 2x. Okay, so sine of 2x equals 2 sine x cos x. So now let's do cos. Okay, so it's the one that's slightly different. Right, let's rewrite it the same way we did for sine. So we're writing it as cos of x plus x to compare it to the compound angle formula. So cos A cos B minus sine A sine B. Okay, so we're looking at cos A plus B there. So A and B are both x, so cos A cos B just becomes cos x times cos x minus sine A sine B. Again, A and B are both x, so that becomes minus sine x sine x. So we have cos squared x minus sine squared x. So this is our first form of cos of 2x. Okay, so having a think back to our first video, there was an important identity that we looked at. So from video 1, recall that sine squared x plus cos squared x equals 1. So what we can do then is we can rearrange our identity, and we can start with sine squared x as the subject. So let's just write here to give some context, rearranging for sine squared x. So sine squared x is equal to 1 minus cos squared x. So we've rearranged our identity, and now what we can do is we can actually substitute this in to our expression for cos of 2x to get a new expression. So let's do that. Cos of 2x equals cos squared x. We're keeping that term the same for now, and we're doing minus sine squared x, but we just saw that sine squared x equals 1 minus cos squared x, and that is from our Pythagorean identity, which we looked at in video 1. So we can say here, what we're doing here is substituting sine squared x into so we're substituting this expression into 2. And so that's going to give us cos of 2x equals cos squared x minus 1 minus cos squared x. That's equal to, so cos squared x minus 1 minus cos squared x. So we have a minus minus. That's going to be plus. So we have cos squared x plus cos squared x. That gives us 2 cos squared x minus 1 there. So cos of 2x, we now have a different expression for our double angle formula for cos, and it's 2 cos squared x minus 1. Okay. Well, because we did that for sine squared x, we can do the same for cos squared x. So now rearrange for cos squared x. It's quite simple. Cos squared x is just 1 minus sine squared x. So now what we're going to do is substitute this expression for cos squared x into our first expression of cos 2x. So that's our formula 2. Okay. So we can write down cos of 2x equals, well, cos squared x, we're going to write down 1 minus sine squared x because we're substituting that in, minus sine squared x. Okay, so what we have here is 1 minus sine squared x minus sine squared x again. So we have 1 minus 2 sine squared x. Okay, so that's our final expression for cos of 2x. Okay, and we'll label that as well. And so the last one we're going to do is tan. So just as we did before, we're going to express tan of 2x as tan x plus x. And let's have a look back at what our compound angle formula for tan is. So it's right here. Tan A plus B is tan A plus tan B over 1 minus tan A tan B. And A and B are both x. So let's rewrite that. So tan A tan x plus tan B, which is just tan x again, over 1 minus tan A tan B, that's just going to be tan x. Okay, let's simplify that a little bit. So tan x plus tan x, that's 2 lots of tan x over 1 minus tan squared x. So that's our double angle formula for tan x, tan of 2x. Okay. So tan of 2x equals 2 tan x over 1 minus tan squared x. Okay, so in the next video, we're going to do some example questions using all the identities and formulae that we've learned up to this point. So I'll see you in the next one.